Now that we've looked at the sum and difference formulas for sine and cosine, we want to look at what follows immediately from that, and that is the double angle formulas. We'll start off with the sine of 2 alpha. Now recall that sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Now, let's suppose that we didn't have sine alpha plus beta. Instead, we had sine alpha plus alpha. Well, that would mean, of course, that every place I had a beta would now be an alpha. And, of course, sine alpha plus alpha could be written as sine 2 alpha. And now notice what we have. We have sine alpha, cosine alpha. And then another one, sine alpha, cosine alpha. So we have 2 of those. So that leads us to sine 2 alpha is equal to 2 sine alpha, cosine alpha. And that is our first double angle identity. Now we go to cosine. Cosine 2 alpha. And once again, we want to recall that cosine alpha plus beta is cosine alpha, cosine beta minus sine alpha, sine beta. And we do the same maneuver here. We say, well, what if instead of alpha plus beta, where we have distinct angles, we have alpha plus alpha? And once again, all the alphas, all the betas are replaced with alpha. And we now have cosine 2 alpha is cosine alpha minus sine alpha, which gives us cosine 2 alpha equals cosine squared alpha minus sine squared alpha. And this is our second our second double angle formula. Now, we want to go a couple of steps further with this cosine one, because oftentimes you'll see a couple of alternative forms for this cosine of 2 alpha. So let's look at the first alternative form. We've already determined that cosine 2 alpha is cosine squared alpha minus sine squared alpha. Now let's suppose we make a little substitution. Let's suppose that we go back and remember our Pythagorean identity that says sine squared alpha plus cosine squared alpha equals 1. That means that cosine squared alpha equals 1 minus sine squared alpha. So we just make a substitution here for cosine squared alpha. Now, let's see what that gives us. Well, noting that we have a negative sine squared alpha here and here, we get that cosine 2 alpha is 1 minus 2 sine squared alpha. So this is another form of this double angle for cosine that you'll see. Now remember, we got that by substituting 1 minus sine squared for cosine squared. Now you might be asking, well, what if we go the other way? What if we substitute in for sine squared 1 minus cosine squared? Well, that's actually where we get the next alternative form. So we start back at our original double angle for cosine. We have cosine 2 alpha is cosine squared alpha minus sine squared alpha. And this time, I'll substitute in. In place of sine squared alpha, I'll substitute 1 minus cosine squared alpha. Then, when I clear my parentheses, notice that this negative and negative here give us a positive cosine. Then the negative with the 1 gives us a negative 1. Putting this together, we have cosine 2 alpha is 2 cosine squared alpha minus 1. And this is another way that we can look at the cosine of 2 alpha.